So here's an LED flickering away, emulating a candle. Cheerful enough, but let's amp it up a bit. Okay, so this little tiny circuit board can't drive this LED array directly. It's a 100 watt LED at about 32 volts at 3 amps. We're going to need to do some design engineering, create a circuit between here and there that can drive it. First things first, took the LED off, and of course now there's a resistor in place, and that allows me to figure out what kind of signal is being generated by the assembly. This is important because we've got to figure out what kind of attributes it has. I'm at 5 volts per division. The scope's telling me it's about 8.4 volts between off and ons. Okay, well let's select a transistor for the driver. I went to my junk box and found this old assembly. It's got a whole bunch of TO220s on it, and that's a good sign that it might have a power transistor on the board. If I zoom into this corner here, I see a TO220 mounted to a big chunk of aluminum. And if I take a look at the readings on it, it says IRF Z44, which is perfect. It's an N-channel MOSFET. I just put the data sheet up and let's check the parameters that are important for this design. It says it's got a VDSS of 60 volts. That's good. I need to operate something around 30 to 40 volts, so that'll be helpful. It looks like it can carry up to 55 amps. That's great. I know we're going to be close to that, so that's helpful. So as a power rating characteristics, that's good. The next thing I got to check is whether or not I can actually drive it, and that's the gate to source voltage. I got about 8 volts. If I pull up this table here called VGS versus ID, I can see that indeed with about 8 volts the transistor turns on quite hard, and that will be suitable. So it looks like this is going to be a really straightforward design. I won't have to do much engineering at all beyond this one transistor. Let's draw this little pad here. We've got 2 boxes on the left, of course, the little LED driver that has the flickering effect on it. On the right, of course, big chunky LED module. Draw the MOSFET in here, and we hook it up. If you notice, there's no additional components required for the assembly, and that's, of course, always the beauty of N-channel MOSFETs. Super easy to use. So let's solder this into the assembly and take a look at what that looks like. Okay, so here's my battery that powers up this LED module. I can put some tape over the solar cells so it stays on. I've got the transistor here and the wire going off to the LED. These 2 leads are going back to a lab power supply. Now this is obviously a pretty dodgy looking assembly, but let's just see if it works to start with. And indeed, looks like that's working fine. I'll just turn it off because it's actually overwhelming the camera. And so yeah, not much else. Now there's of course some problems here. This really long lead wire, actually, I suspect this thing will be spraying out a lot of RF energy as well. You want to have some snubbers. You don't want to drive like this with big long leads, but as a proof of concept, looking good. Okay, well I've shielded the camera by pointing the light actually away from it. It's so bright, it's actually lighting up my entire room here, flickering away. I actually cranked the voltage up to 45 volts and I'm doing about 200 milliamps, so what is that, about 10 watts. So nice bright flickering effect. In terms of thermal management, I thought I'd have a whole section of this video, but it turns out just a chunk of aluminum was more than sufficient. I was going to have a little thermocouple and show that the temperature would rise, but it doesn't actually. Just this amount of aluminum is sufficient to draw the heat away.